Hello class, this is Ms. Martins. Welcome back. We are in Unit 7 Solutions. This is going to be our second lesson today. Our first lesson was reviewing Table F. We were able to differentiate between the definition of solute and solvent and a soluble substance versus an insoluble substance. We were able to also use Table F in order to determine whether a compound was soluble or insoluble. Today, we'll be able to describe solubility and level of saturation using Table G. So what I want you guys to do now is to describe solubility in your own words. I know a lot of you may be coming in with pre-existing knowledge of what solubility means. So just take a moment to try to reiterate to yourself what solubility means to you. Are there any conditions that may increase the solubility of a substance? In other words, what can you do in order to speed up how fast a solute dissolves in a solvent? So I know usually when we're in class, you guys will be able to answer these questions in your notebook. You can feel free to pause the video at any time, answer the questions, and then come back. So once again, are there any conditions that may increase the solubility of a substance? So by solubility, we mean, in other words, what can you do in order to speed up how fast a solute dissolves in a solvent? You can add heat, stir or shake, or make your solute have smaller particles. So these are a few things that you can do in order to increase the solubility, or in other words, how fast a solute dissolves in a solvent. If you feel that I'm moving a little quickly, feel free to pause the video and watch it as many times as you need to. So solubility in chemistry terms is the ability of a solute to dissolve in a solvent. Once again, it's the ability of a solute to dissolve in a solvent. Saturated is the maximum amount of solute a solvent can hold at any given temperature. Unsaturated, the solvent is not at maximum capacity and can hold more solute. Supersaturated, more solute is present than solvent can hold. So you may see a precipitant at the bottom. Some images that'll help reiterate those vocabulary words. Once again, you can pause the video, take notes of the vocabulary word, make sure that you understand it before moving on. So we have an unsaturated solution here, which is saturation is the capacity of measuring, a measure of capacity once again. So an unsaturated solution is not full. A saturated solution is full. These both types of instances are stable conditions. Whereas we have a supersaturated solution, which is too full and is unstable. So basics, Table G. Table G is going to allow us to understand whether a solution is saturated, supersaturated, or unsaturated. But before we get into that, we'll be just looking at Table G. So the title of Table G is Table G. The title of the x-axis is temperature, and the units are in degrees Celsius. So this is going to be very important to note when answering questions. The title of the y-axis is solubility. So again, how well the solute dissolves in the solvent. And the units are grams of solute per 100 grams of water. So all of these solutions that we're going to be looked at are aqueous solutions, which means that it is mixed with water. Welcome to Table G. I know this may seem a little bit overwhelming. However, we're just going to look at Table G using one solubility curve for KNO3. So for example, if I were to give you a measurement of 30 degrees Celsius and ask you to look at 50 grams of solute, that would be a saturated solution because it is on the line. If I were to give you measurements that lied above the line, that would be a supersaturated solution. If I were to give you measurements that were below the line, that would be an unsaturated solution. However, this could be a bit difficult without looking at examples, so let's do that first. How many grams of NaNO3 is necessary to saturate a 100-gram solution at 35 degrees Celsius? So remember, saturation is on the line. So we're going to go to 35 degrees first. So that's between the 30 and the 40, about here. And we're going to look for the NaNO3 line, which is here. Remember, We're using a 100-gram solution, which is what the units are telling us. It's a 100-gram solution of water. So we're trying to determine how many grams of NO3 is necessary to saturate. So we want it to be saturated. So at 35 degrees, I want to be saturated. So I'm looking to be on the line. That is 100 grams of solution. So the answer, 100 grams of NaNO3. So the answer is 100 grams of NaNO3. Saturated at 35 degrees. Because I go up to 35 degrees, which is here, NaNO3, 100 grams. Perfect. Next example. How many grams of NaNO3 is necessary to saturate a 50-gram solution? So our table G is based on 100-gram solution. So if they're asking us for a 50-gram solution, you would just cut whatever answer you have in half. So at 35 degrees, we're at 100 grams, which we figured out in the last example. And I would just cut 100 grams in half, and that would be 50 grams of NaNO3 is saturated at 35 degrees Celsius in 50 grams of water. Remember, table G is looking at 100 grams of water. But if the question asks us for 50 grams of solution, we would have to cut whatever grams we get in half. So let's look at other types of problems. Given a specific temperature and amount of grams per water, grams of solution per water, we're going to determine if a substance is unsaturated, supersaturated, or saturated. So the first example is NaNO3 at a temperature of 50 degrees Celsius and 130 grams. So I'm going to go to 50 degrees Celsius. I'm going to look for my curve NaNO3. This is my curve. And they're asking us 130 grams. So 130 grams is here. This is my line for NO3 at 50 degrees. 130 is here. My point is above our line. So that is going to be a supersaturated solution. Now we have KClO3 at temperature 75 degrees, and our grams is 20 grams. So at 75 and 20 grams, I'm looking at the line KClO3, which is right here. I know that my point is below the line, so that is a unsaturated solution. For our next example, we have KNO3 at 25 degrees Celsius and 40 grams. So KNO3 is right here. 25 degrees Celsius is about here, and 40 grams is here. There are so many different lines. However, I know this is my KNO3 line here, and I'm at 25 and 40, and that is exactly on the KNO3 line. So therefore, this is a saturated solution. And for our last example, we have potassium iodide, the Ki line, which is all the way up here. Our temperature is 10 degrees, and our grams is 145, which is approximately here. That is above the line, so this is a supersaturated solution. So if you had any difficulty with all these examples that I went through, please feel free to watch this video as much times as possible. With that being said, go to Google Classroom and click on the link to the assignment for exit ticket, Table G, and complete the 5-question Google form. If you're not confident after watching this video, please make sure that you review the video as many times as you need. I will also be going live today at 1 p.m. to review this material and yesterday's material. If you have any questions also, please email me or ask during our regularly scheduled class times. Feel free to post in the comments and I will be there to help you. Hope you enjoy your day. Take care.